Welcome to the University of Kentucky's Center for Applied Artificial Intelligence. Visit us online at caai.ai.uky.edu to learn more.
Hi, I'm Emily Collier with the Center for Applied AI at the University of Kentucky. In this video, we'll unpack what makes artificial intelligence tick by exploring how machines learn patterns, why they sometimes seem creative, and what this means for how we work, discover, and use it in our everyday lives. So, what is it that defines human intelligence? We might say it's our ability to think or understand. More acutely, we might say that humans have the ability to recognize patterns, solve problems, or adapt to change. Now, imagine teaching a machine to do those same things. This is where we enter the realm of artificial intelligence, where computers can be taught to recognize faces, write essays, generate images, or even produce scientific hypotheses. Our conversations with Alexa, Siri, ChatGPT, or Claude, they feel surprisingly human. Is AI using intuition or imagination? Is it drawing meaning from experience? We might say that those are strictly human abilities. So why does it seem like that streaming playlist knows our mood? It feels like magic. But it's because AI is following patterns that come from data. And like how all computer programs work, this recognition of patterns is based on mathematical algorithms. So no magic, just math, but powerful math. Math that can identify a tumor, translate a language, or spit out a research paper in seconds. So what exactly is AI? Artificial intelligence isn't a single technology or an all-powerful algorithm. It's a collection of systems that can perform tasks, usually tasks we'd think of as requiring human intelligence. Recognizing patterns, understanding language, interpreting images. So when we talk about AI, it helps to think of it as an umbrella, a broad field that has many different tools and techniques. So under the umbrella are things like machine learning, computer vision, and natural language processing, each designed for specific types of tasks. So what ties them together are three essential ingredients: data, that raw material that the AI learns from; algorithms or models, those structures that find the patterns in that data; and computing power, the engines that process the data within the models. And when these things come together, rich data, effective models, and powerful computers, these systems can do remarkable things. And while AI capabilities are growing every day, they are still limited by these three ingredients. So for example, if you feed an AI system thousands of X-rays, it can learn to spot patterns that suggest pneumonia. But it doesn't know what pneumonia is. It only knows that certain patterns of pixels tend to appear when humans have labeled an image in that way. So if our data is mislabeled, our AI system will produce incorrect results. So AI imitates a certain aspect of human thought, perception, prediction, and even creativity, but it doesn't feel or think or reason like we do. That's why calling AI intelligent is a bit of a misnomer. It's not thinking, it's calculating. But this calculating is a bit different than what we might think of as an automation or traditional software. Automation follows fixed instructions. If X happens, then do Y. Traditional software is much the same. Human-written rules telling a computer exactly what to do. AI, though, learns the rules from the data instead of being told what they are. So imagine the difference between a cookbook and a chef. A cookbook is like an automation. It follows recipes exactly. An AI system is more like a chef who's learned from the thousands of meals. It can improvise when the ingredients or conditions change. But this doesn't make AI magic. It's still limited by its recipes, or in this case, its data. So that's why later in this series, we'll talk about how data is the real key to how AI learns. Most of today's AI systems are what we call narrow or specialized. They're trained to perform one task: translate a sentence, recognize a tumor, or drive a car. Today, we are seeing a rise in more broad AI, like multimodal large language models, that are fairly general purpose. They can write, summarize, translate, or reason through problems, turn words into pictures, and even turn speech into text. But general doesn't mean unlimited. These models are flexible, yes, but they aren't experts in the same way that narrow or specialized models are. So a system that can chat about chemistry might still make a mistake in basic math errors. So rather than thinking of AI as narrow versus general, it might be more accurate to say that it sits on a spectrum. either highly specialized systems that can perform one task with precision, versus broader models that can adopt across different contexts, although this is often at the expense of depth or accuracy. Understanding where a system or model sits on that spectrum can help us set realistic expectations and helps us use it more critically, creatively, and responsibly. So we've seen that AI isn't a single machine or mysterious mind, it's a collection of systems designed to recognize patterns, learn from data, and support human decision making. It can seem creative or intelligent, but what's really happening is powerful computation. Tools built on data, models, and math that help us see more, learn faster, and imagine new possibilities. At the Center for Applied Artificial Intelligence, we study how these systems work with people to improve research, advance healthcare, and make discovery more accessible to everyone. In our next video, we'll look at how AI learns through the branches of learning, reasoning, and perceiving, and how these come together to shape intelligent systems.